Investigating Resistive Forces, Group 1A, Nick Pride, Sophia Sokensange, and Morgan Henry.
An introduction to viscosity. As an object moves through a fluid, a thin layer of this fluid covers the object and interacts with neighboring molecules of the rest of the fluid. This interaction slows the motion of the object. We find that as the object reaches a constant speed, the acceleration is zero, leading to the following equation. A couple other rules to know are that the force of the viscosity is proportional to the speed and area of the object. For this experiment, we want to find the proportionality constant, the equation for which is as follows. Specifically for this case, the viscous force on a sphere of a radius r moving in a fluid is
System schema and free body diagram. In the system schema for our experiment, each aspect has a contact or a gravitational relationship with each other. A ball bearing, a liquid, Earth, and our graduate cylinder are all included in the system schema.
For the free body diagram, there's the force of viscosity in the upwards direction and the force of gravity in the downwards direction. The experiment. Our research question was, how are the resistive force and velocity related in different forms of liquids? The goal of the experiment was to determine how different media affect the velocity of a metal ball bearing. The variable changed in this experiment was the fluid's viscosity through which the object was traveling. The fluids we used were water, isopropyl alcohol, and corn syrup. The variables kept the same were the object moving through the fluid, the amount of fluid, and the beginning height of the object. Values of the velocities and their relationships. Terminal velocities. Water is equal to negative 91.2 centimeters per second. Alcohol is equal to negative 88.2 centimeters per second. Corn syrup is equal to negative 1.3 centimeters per second. The relationship was determined to be the terminal velocity is inversely related to the viscosity for all.
The relevant models to the system and scientific reasoning. Both friction and viscosity are opposite the applied force. They both have a constant coefficient that is dependent upon what the object is dragged against or traveling through. The differences between friction and viscosity are the viscosity of the liquid will decrease when the liquid is heated up, whereas the friction is completely independent of temperature. The heat generated between the interaction of the two objects in friction is applied to both surfaces, whereas the heat generated when a solid moves through a liquid is generated only in the liquid. In this experiment, when the metal ball bearing is dropped into one of the fluids, the viscosity of the liquid has an effect on the velocity of the ball. We found that the terminal velocities were inversely proportional to the viscosity. This was found by using the constant velocities of each graph and discovering what terminal velocities they had. Then we did the inverse and plotted those against the viscosity. The alcohol and water were very close in their terminal velocities and their viscosities. The corn syrup, however, was much further away for viscosity and for its terminal velocity.
For our experimental design, the instruments used were a metal ball bearing, a 50 milliliter glass graduated cylinder, a tracker software, and Excel spreadsheets. Step 1, choose 3 different fluids to test a metal ball bearing in. In this experiment, test water, isopropyl alcohol, and corn syrup. Step 2, place a 50 milliliter glass graduated cylinder on a flat surface and against a solid background for best accuracy. Step 3, fill a graduated cylinder with water using a camera, record video of the metal ball bearing being dropped inside the cylinder from the top to the bottom. Repeat this process with both corn syrup and isopropyl alcohol. Step 5, upload videos to tracker software and create a motion map to track the metal ball bearing's movement. Step 6, transfer this data into Excel spreadsheets and calculate the average velocity of the ball for each solution used. Step 7, report your findings. Possible errors made are limited precision of tracker software and limited precision of graduated cylinder.